All right, so this is the line y equals 1 right here, right? This line. We'll put that in purple. Let's put the next one in black. That's going to be y equals -1, which is this line. So we're going between those two lines. Yeah, this makes it prettier. And then we want to get between the parabola. So the part between those, the black and the purple line is this part. And then the part of the natural log graph. Oops, that's purple line. And red. Is this part between there. Yes. Thanks for straightening me out on that. We want this part. Now, we could do top minus bottom and do a dx problem here, but it's going to be really nasty. And here's why. If you look from the blue part, from the shaded part right here, the part of the parabola here is above the other part of the parabola here. So you would have to break this up into many parts, because you would first have to do this blue from -2 to -1 of this blue minus that blue. And then you would start on this purple minus this black just for this part, because purple's above the black. And then you'd have to break it up into purple over red. You see how nasty that's going to be when you do top minus bottom? That would be really nasty. But if you look at the right minus the left, you see the red is to the right and the blue's to the left the whole time. So that's why we want a dy problem. Another hint to dy is, you see that they're putting the equations with the parts we want, they solve them for x. So when they solve them for x, a lot of times that's going to be a dy problem. So what you're supposed to learn is, if it's a dy problem, the way you do the integral is you do the bottom y value, bottom y to the top y, and then it's going to be the right function minus the left function dy, and these have to be in terms of y. So if you look, the red's on the right the whole time. You see it? You see how that simplifies doing the red minus, or the right minus the left? The red is minus the blue the whole time. So that makes it easier, because you're only going to have one integral instead of breaking it up into 3. So that's why you didn't want to do a dx on this one. Okay, so what's my bottom y value? So we got -1. What's my top y value? 1. From this black to that purple. Then what's the function on the right side? E to the y. We got to have y in here. See that y? If you put an x in there, it's not going to be right, because we're doing dy problem. So it's that e to the y minus the blue one, which is minus y squared minus 2. Now, when I did this before, I sent out an email or a remind yesterday, I think it was, but I screwed this problem up because I was in a hurry to do it. I did not distribute the negative sign. I told you I made a simple algebra mistake. I did. So I did not distribute the negative, so my notes were wrong on this before. So I would distribute the negative before I do the integral, is what I would do. And you would have this. See, I left that -2, which was wrong. So when you do this problem, the integral of e to the y is e to the y. The integral of -y squared is -y cubed over 3. And the integral of 2 is 2y, and we're doing this from -1 to 1. The lower bound is -1, the upper bound is 1, is what they call those. Lower bound, upper bound. Really, you getting all this? Okay, you fixing your notes? You copied mine down if they're wrong. So then you plug in which one first? Nope. Oh. Top minus, it's the top one, and then minus the bottom one. Okay, so now we got to distribute this negative sign and simplify all this stuff. So I got e to the first minus the third plus 2. I'm going to distribute and simplify this. So this is minus e to the negative 1. If you want to put that over 1 over e, you can. By the way, on your test, you can stop right there if it's not multiple choice. Right? You don't have to simplify. And then we distribute negative to negative is a positive. Negative 1 to the third is a negative. So this is still minus 1/3. And then this is negative 2 here. And you take the negative to negative 2. That makes that positive 2. So this is going to equal, let's say, e to the first minus 1 over e. I don't know. We could get common denominators. You can do all kinds of things with that. And then we got negative 2/3 plus 4. And we probably want to put these two together. So we got e to the first minus 1 over e to the first. Again, you can leave that e to the negative 1. So biggie. And 4 minus 2/3, I believe, would be a positive 3 and 1/3. I believe. So this right here is what we should have gotten for that problem.